Compared to old technology aircraft, the flight deck on the A330 is designed to be a comfortable, uncluttered environment in which to work. By utilizing modern electronic display units, the presentation of information to the pilots has been improved. The Electronic Instrument System, EIS, consists of 6 identical full-color cathode ray tube display units. The EIS is divided into 2 subsystems: the Electronic Flight Instrument System, EFIS, for which each pilot has 2 displays; the Electronic Centralized Aircraft Monitoring System, ECAM, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the EFIS system first. Flight parameters are displayed on primary flight displays, PFDs, while navigation data is displayed on navigation displays, NDs. Outboard of the PFD are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off. A switch is provided to allow the information on the PFD and ND displays to be transferred. The use of this switch will be explained in the EIS reconfiguration module. At the top of this panel, a switch allows the pilot to manually select the data source for his PFD-ND. You will use this switch in the EIS reconfiguration module. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System. At this stage, we will simply introduce the ECAM displays and associated controls. In later modules, the ECAM system will be studied in detail. The upper ECAM display is known as the Engine Warning Display, EWD. The lower ECAM display is known as the System Display, SD. It is on this screen that various aircraft system parameters can be viewed by the pilots. As an example, we will cycle through the system pages for you. The presentation of system information is based on a need-to-know philosophy. This means that only the system information relevant to the particular phase of flight is presented to the pilots. You will see this demonstrated in the normal and abnormal operation modules. Another philosophy that is used on the flight deck is the lights out principle. What this means is that when the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. As an example, just before takeoff, if you look up at the overhead panel, there should be no white lights illuminated on any of the switches. Let's look at some switches and show the different possibilities. For the majority of the switches on the overhead panel, the push-button switch logic is normal operation configuration, no lights showing, the lights out philosophy. Abnormal condition, amber fault light. This assists identification of the switch associated with an abnormal condition. Abnormally deactivated or activated systems, white light. If the system should normally be operating and is deactivated, a white off light is illuminated. If the system should normally not be operating and is activated, a white on light is illuminated. There are some switches on the overhead panel which are used on a temporary basis, or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light, for example, anti-ice, and applicable system status, green light, for example, APU available. You will see this philosophy demonstrated throughout the course. Below the ECAM displays on the center pedestal is the ECAM control panel. The two controls on the left-hand side are to adjust the brightness of the two ECAM screens or to turn them off. We will look at the rest of the controls on this panel in more detail later. Just to the left of the ECAM lower screen is a switching panel for use in abnormal situations to restore data to the ECAM displays. You will use this panel in the EIS reconfiguration module. In front of each pilot there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note, the loudspeakers can also be used to listen to radio communications and the intercom. Now, let's go back to the EFIS system. For the EFIS displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management Guidance and Envelope System, FMGES, is fed directly to three display management computers, DMC. The three identical display management computers process the data and generate the images to be displayed. Under normal circumstances, DMC-1 supplies EFIS information to the captain's PFD and ND. DMC-2 supplies the first officer's PFD and ND. And DMC-3 is available as a backup. You will see the use of DMC-3 in the Abnormal Operation module. Now, let's look at the other EIS subsystem, ECAM, and how the ECAM displays gets its data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated in the flight deck. Data for certain parameters, for example fuel quantity and primary engine indications, is routed directly from the system sensors to the three display management computers. Note that there are separate channels within each DMC for ECAM and EFIS. For the majority of the systems, the sensors supply data to two System Data Acquisition Concentrators, SDAC. The SDACs acquire system data, process it, and send system page data to the three display management computers. Normally, DMC-3 supplies the ECAM system, and DMC-1 and 2 are available as backup. Two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings and the SDACs to generate amber cautions. The flight warning computers then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts and synthetic voice messages.
Speed, speed, speed.
All the components shown can be collectively called the ECAM system. We will study the use of the ECAM system in a separate module. In addition to EFIS and ECAM, time measurement devices are provided. The master time reference for all aircraft systems is provided by a clock, located on the right lower side of the main panel. In this example, the time is 13:28. The time is also displayed at the bottom of the system display. Adjustment of the time is achieved by using the UTC selector and the set knob. You will have the opportunity to do this in the simulator. The set knob can also be pressed to display date information in the order month, then day. In this example, the date is July 4th. There are chronograph and elapsed time facilities on the clock. These functions will be covered later. In this module, we have introduced you to the Electronic Instrument System, with its two subsections, EFIS and ECAM, and the clock. In the next modules, we will concentrate mainly on the ECAM system, and then later in the course return to look at the EFIS displays in greater detail. The ECAM system keeps a watchful eye on all of the aircraft systems, monitoring them for any abnormal states. If something abnormal is detected, ECAM will alert the pilots and provide an electronic checklist to help handle the abnormality. The two ECAM displays, the engine warning display and the system display, are where the ECAM system provides normal and abnormal system information to the pilots. Color coding is used on the ECAM screens for clarity and to aid identification of abnormal parameters. The main colors used are white, blue, green, amber, and red. During the course, you will become familiar with the use of this color coding. Let's start with the last three, green, amber, and red, which are the most important. Green color coding is used to indicate a normal condition. Notice that on the engine warning display and the system display shown, all indications are normal. Amber color coding is reserved for abnormal indications that require crew awareness but not immediate crew action. Notice on the engine and warning display the amber failure message and on the system display the amber indications. Red color coding is reserved for serious parameter exceedance and warnings that require immediate crew action. Notice on the engine and warning display the red parameter indication and the red warning message. Let's now look at the two ECAM displays in a little more detail. The engine and warning display is divided into two main parts. The upper area is used for the main engine parameters, fuel on board and slat flap position. These indications will be discussed in the appropriate system modules. Under normal conditions, the lower part of the engine and warning display is used to display memos. In the example shown, the memos indicate that the seatbelt and no smoking signs are switched on and that the APU is available for use. If failures occur, warning or caution messages are displayed in place of the memos. In the example shown, there is an amber caution message with a series of blue action items. These action items are your electronic checklist to respond to the particular abnormal situation. The system display is used to display particular system information. In the example shown, the cruise page is displayed. This is the page normally seen for the majority of the time that the aircraft is airborne. Useful information from several systems is displayed during flight. The individual indications will be covered in the appropriate system modules. The system display can also be used to display synoptic diagrams of the aircraft systems, system pages. In the example shown, the hydraulics system page has been called. You will see later how these system pages are called either manually or automatically. An aircraft status page may be displayed on the system display to check the state of the aircraft. A normal message is displayed to indicate that the aircraft state is normal and that there are no inoperative systems. Let's see what the status page looks like when things are not normal, for example, following a system failure. The information displayed on the status page will vary depending on the failure, but, as an example, can include limitations, approach procedures including actions and corrections, information, and inoperative systems. The area at the bottom of any system display contains permanent data: total air temperature, TAT, static air temperature, SAT, time, gross weight, and gross weight center of gravity. Individual airlines can choose which units they wish to use for certain parameters on the ECAM screens. In the examples shown, we have highlighted the areas on the screens where the units used are different. Because these indications are only mentioned in a few areas of the ground school course, we will use boxes to indicate that the units may differ depending on your airline's choice. The boxes mean that the information in this area of the screen is irrelevant to the system being studied. When a system, for example fuel, is being studied, the appropriate unit values will be shown. Under normal conditions, the ECAM system provides the pilots with the information that they need to know for the particular phase of flight, no more, no less. As an example, during the approach, when the landing gear is extended, the ECAM wheel system page is automatically displayed. The ECAM system divides the various stages of a flight into phases, from initial electrical power-up until after engine shutdown. The ECAM system will avoid alerting the pilots unnecessarily during the critical flight phases of takeoff and landing. The warnings and cautions that can be delayed until a less critical phase of flight will be inhibited. We will now look at the different ways that the ECAM system advises you when things are not going exactly right. We will start with a minor advice indication and work up to a major fault, concentrating on the two ECAM screens. If a system parameter, for example an engine vibration level, approaches a limit, the ECAM system will advise you of this by displaying the relevant system page on the system display. The affected parameter will pulse. Notice that at this stage the parameter is still shown in green since it is still within normal limits. This is known as an ECAM advisory. Now, let's look at what happens when ECAM detects a minor system failure. When a failure occurs, leading to a loss of redundancy or loss of a system that does not affect the safety of the flight, for example, digital flight data recorder fault, the ECAM system will inform you by displaying an amber caution message on the engine and warning display. At the same time, the two clear keys on the ECAM control panel will illuminate. The first action is to ensure that the aircraft is on a safe flight path. This fault only requires crew awareness, so, if required, the handling of the fault can be delayed. Normally, the pilot non-flying carries out the ECAM procedure, while the pilot flying is responsible for the aircraft flight path. For this exercise, you are the pilot non-flying. Read the title of the failure, in this case, Recorder DFDR Fault. The pilot flying will ask you to perform ECAM actions. In this case, there are no actions required, so, after confirmation from the pilot flying, the caution message can be cleared by pressing one of the clear keys on the ECAM control panel. Press a clear key. As a result of pressing either clear key, the caution message has been cleared from the engine and warning display, and the status page is displayed automatically. In this example, you can see that the inoperative system is the digital flight data recorder. On the ECAM control panel, the status key is illuminated along with the two clear keys. When safe to do so, the status page is reviewed by both pilots. After confirmation from the pilot flying, the status page is cleared by pressing either the status key or one of the clear keys. Clear the status page. Notice that, on the engine and warning display, there is a boxed status caption to tell you that there is information on the status page, and on the ECAM control panel there are no lights. The ECAM actions for the digital flight data recorder fault are complete. We will now look at what happens when a slightly more serious fault is detected by ECAM. The fault that we will use is an overheat of the blue hydraulic system reservoir. We will concentrate on the use of the ECAM system, how it alerts you, and how it helps you to deal with the fault. The hydraulic indications themselves will be covered in the appropriate modules. Click on the forward arrow to initiate the failure. When the fault occurs, the ECAM system alerts the crew orally and visually. You will hear a single chime and see the master caution lights. To cancel the master caution lights and reset the alerting system, one of the master caution push buttons must be pressed. Extinguish the master caution light. The master caution is extinguished and the alerting system is reset. The first priority is always to ensure the safe flight path of the aircraft before dealing with the fault. The master caution means that the abnormal situation needs crew awareness, but not immediate action. The indications are a failure message on the engine and warning display. The system's synoptic associated with the fault is automatically displayed on the system display, and the clear keys on the ECAM control panel light up. Let's study the details on the engine and warning display first. The system title is underlined, in this case hydraulics, and the fault is shown alongside, blue reservoir overheat. Notice that abbreviations are used. If you look carefully at the hydraulic system display, you will notice an amber overheat message is displayed. This abnormal indication is how the fault is shown on the system synoptic. The pilot flying will ask you to perform the ECAM actions. In this example, there is a blue action line on the engine and warning display telling you to switch off the blue engine 1 pump. Let's check the overhead panel. On the overhead panel, amber fault lights are illuminated on the hydraulic control panel. The fault lights on the hydraulic panel help you to locate the switches to be operated. We will carry out the action for you. When the pumps are switched off, the action lines are removed. The blue hydraulic system depressurizes as shown on the hydraulic page by the amber indications. The ECAM system detects the drop in pressure and generates a further alert. You hear the chime and see the master caution lights. Extinguish the master caution lights. There is now a new abnormal message on the engine and warning display. Blue system low pressure. The message is boxed to indicate that the loss of the blue hydraulic system is classed as a primary failure that will affect other systems. The systems affected are shown on the right of the engine and warning display as starred items called secondary failures. In this example, the primary failure of the blue hydraulic system has caused a secondary failure of the flight controls. After review and confirmation from the pilot flying, the hydraulic failure message on the engine and warning display can be cleared. Clear the hydraulics message. Notice that normal memos have returned on the left side of the engine and warning display. The ECAM Flight Control System page is displayed on the system display, which corresponds to the secondary failure item on the engine and warning display. On the ECAM Flight Control page, notice that the controls affected by the loss of blue hydraulics have amber indications. These indications will be discussed in the hydraulic and flight control modules. After review and confirmation from the pilot flying, the flight control secondary failure message can be cleared. Clear flight control. Notice that the secondary failure indication on the engine and warning display is removed. The status page is now displayed, containing several pieces of information. The first area gives procedures to be applied for approach, landing distance factors, and other information. You will study the procedures in the appropriate system lessons.
In this example, the inoperative systems are blue hydraulic. The system was switched off during the ECAM procedure. Part spoilers. Some spoilers are inoperative because there is no blue hydraulic pressure. REV1, reverse 1 inoperative, only for Pratt & Whitney or Rolls-Royce engines. Cat 3 dual, which means that Category 3 Autoland with both autopilots is not available. Alternate braking. The alternate braking is inoperative because there is no blue hydraulic pressure.
The status page is reviewed by both pilots. After confirmation from the pilot flying, the status page can be cleared. Clear the status page. The ECAM actions for a blue hydraulic reservoir overheat are complete. Notice that the status reminder is displayed at the bottom of the engine and warning display, reminding you that there is information on the status page. This is important since there were approach procedures to be applied. If it contains information, the ECAM system automatically recalls the status page during the approach phase when the slats are extended or the QNH is set. This always happens when there are any items affecting the approach and landing. They will be presented to you at an early stage. You can see that in the examples shown there are approach procedures. You will see how these approach procedures are applied later in the course. Clear the status page. The status page is cleared and the cruise page is displayed. So far, we have looked at how the ECAM system advises you of minor failures. We will now look at what happens when there is a serious failure that requires immediate action. To demonstrate this, we will use an engine fire. As before, we will not concentrate on the system failure, but on ECAM indications and procedures. Be ready to cancel the warning by pressing a master warning push button. Click on the forward arrow to initiate the failure. When the fault occurs, the ECAM system alerts the crew orally and visually. You hear a continuous repetitive chime and see the master warning lights flashing. Press one of the master warning push buttons to cancel the master warning lights, stop the chimes, and reset the alerting system. On the engine and warning display, the red message Engine 1 Fire and the associated procedure are displayed. The red indications on the fire panel and the engine panel provide confirmation and identification of the affected engine. The engine page has automatically been called on the system display, and, in this example, the nacelle temperature needle is pulsing. Notice that there is a red Land ASAP message on the engine and warning display. This means that ECAM has determined that the fault detected is serious enough to require a landing as soon as possible. The pilot flying maintains control of the aircraft and asks you, as pilot non-flying, to start the procedure. We will do the ECAM actions for you, starting with setting thrust lever 1 to idle. The next line on the ECAM procedure has now to be carried out. After confirmation, we will switch engine 1 off for you. After switching engine 1 off, the after engine 1 shutdown procedure is shown on the engine and warning display. Notice that the amber caution message has appeared below the red warning. This happens because you have to finish the engine fire procedure first before carrying out the actions for engine 1 shutdown. The ECAM system has automatically allocated priority to the warning. As a result of switching off the engine, there are now secondary failures. The next ECAM action is to push the engine 1 fire push button. We will do this for you. Notice that there is a white line in the abnormal checklist. In this example, there is a delay in discharging the agent to let the engine spool down. We have paused the countdown at 10 seconds. To continue the countdown, click on the forward arrow. When the countdown is complete, a blue action line appears, telling you to discharge the first fire bottle. We will do this for you. The next action line is to notify ATC. Since the ECAM system cannot tell when you are talking, there is no feedback, so this line will not disappear. Notice that we still have a red fire indication, which means that the fire is not extinguished. Another condition line has appeared, and a second countdown automatically starts. This one is 30 seconds long. We have paused the countdown. To continue the countdown, click on the forward arrow. Agent 1 managed to extinguish the fire. The countdown for Agent 2 stopped immediately. Notice that the engine fire procedure on the ECAM disappeared. This means the fire is out. The local warnings on the fire panel and the engine panel are no longer illuminated, confirming that the fire is out. And Land ASAP has changed from red to amber, which means that ECAM has determined that the fault is less critical but still requires a landing as soon as possible. The remaining steps are similar to those seen for an ECAM caution, so we will stop here. You have seen that the ECAM system has provided a smart and interactive checklist to help you deal with a major problem. So far, the messages and procedures displayed on the engine and warning display have not been more than 7 lines, so we have had room to display them all. Let's look at how ECAM copes with a long procedure. In this example, the indications for an engine fire on the ground, there is an overflow arrow to indicate that there is more information to be seen. For training purposes, we have shown the rest of the procedure below the engine warning display. We will complete the ECAM actions and you will see the associated line of the procedure disappear. As actions are completed, the rest of the information will be displayed and the overflow arrow will be removed. For this particular failure, on the status page, an overflow arrow also indicates that there is further information to be seen on a second page. By pressing a clear key, the next page can be displayed. Press a clear key. The second page of status information is displayed. Notice that the list of inoperative systems has not changed and that there is still an overflow arrow. Press a clear key. The second page of inoperative systems is displayed. There is still an overflow arrow indicating that there is more to be seen. Press a clear key. The last page of inoperative systems is displayed and the overflow arrow is removed. If you want to display the first status page again, the status key can be pressed. Press the status key. We are now back at the first status page again. You will have the opportunity to practice moving between status pages in the simulator, so we will stop here. To summarize, initially you see all the information on the left side of the status page, and then all the inoperative systems on the right. To complete this module, let's briefly look at ECAM priority. We will only use the bottom part of the engine and warning display for this demonstration. You are partway through the Engine 1 fire procedure when ECAM detects another failure. The low priority recorder DFDR fault has appeared below the higher priority Engine 1 fire and Engine 1 shutdown procedures. Unfortunately, it is one of those days and another failure occurs. The autopilot off warning has appeared above the Engine 1 fire procedure. ECAM has automatically assigned priority to the autopilot off message because the first priority is always to fly the aircraft. The low priority recorder DFDR fault is now off the screen. You are advised that the fault is there by the unstarred recorder text in the right-hand column of the engine and warning display and the green overflow arrow. We will clear the Autoflight Autopilot Off warning for you. The recorder DFDR fault message is back at the bottom of the engine and warning display, and the recorder text has been removed from the right-hand column. In this module, we have discussed the ECAM system. You have seen the various failure levels and how the ECAM system alerts, indicates, and helps you deal with a failure. Throughout the ground school course and during your simulator sessions, you will have the opportunity to practice ECAM procedures. When you first enter the cockpit, all the EIS displays are normally off. The displays require alternating current electrical power to operate, so, unless either the APU or a ground electrical supply are available, the displays will not operate. We will connect a ground electrical supply for you. Normally, the ECAM screens are switched on in the following order: upper, then lower. For training purposes, let's switch them on in reverse order to see what happens. Switch on the lower ECAM display. Notice that engine warning display information is displayed on the lower ECAM screen. This occurs because it has priority. Therefore, if there is only one ECAM screen available, the engine warning display information will be displayed. Now, switch on the upper ECAM display to see what happens. Switch on the upper ECAM display. Notice that the engine warning display information moves to its normal position on the upper ECAM screen, and the door oxygen system page is displayed on the lower ECAM screen. The door oxygen page is what the ECAM system will automatically display because you are on the ground with the doors open. The memo area of the engine warning display has a message telling you that refueling is taking place. We will now start the APU. Click on the APU picture. Notice that the APU system page is automatically displayed by the ECAM system, and there is no light on the ECAM control panel APU push button because the APU page has been automatically called as part of a normal sequence. The APU is now running. Once the APU has been started, the ECAM door oxygen page is automatically recalled. As the external power is no longer needed, we have disconnected it for you. The next action is to press the recall push button on the ECAM control panel. Pressing this push button recalls any warnings or cautions that have been cleared since the last power-up. Press the recall push button. Since we are starting the aircraft from cold, a normal memo will be seen on the engine warning display because there is nothing to be recalled. If we were on a turnaround, the display would recall any warnings or cautions that had occurred during the previous flight. In this example, a cleared caution concerning the digital flight data recorder has been recalled. You will see how a caution is cleared in the Abnormal Operation module. During the pre-flight check, one of the things we do is check fluid levels. For example, the quantity levels for hydraulic fluid and engine oil. The required system pages are manually called by pressing the associated key on the ECAM control panel. Let's call the ECAM hydraulic system page. Press the hydraulic system key on the ECAM control panel. The ECAM hydraulic system page is displayed. Notice that there is a light on the hydraulic key on the ECAM control panel to indicate that it was manually selected. You will do the fluid level check in the hydraulic module, so let's see how to return to the ECAM door oxygen page. To deselect a manually selected ECAM page, the lighted key on the ECAM control panel is pressed. Press the hydraulic key on the ECAM control panel. The ECAM door oxygen page is displayed, and there are no lights on the ECAM control panel. Remember the lights out philosophy, which also applies to the ECAM control panel. The switching panel is checked to confirm that all the switches are in their normal position. The passengers have boarded, the doors have been closed, and the aircraft is ready for pushback. Notice that, on the door oxygen page, there are green indications on all the doors, which means you are in a go state. When the ground personnel attaches a tow bar to the aircraft, they disconnect part of the nose wheel steering system. The ECAM system will detect this and provide a green memo indication, nose wheel steering disconnect. Let's start the engines. Click on the engine to start it. The ECAM system will automatically display the ECAM engine page while the engines are being started. Notice that, as soon as the first engine is running, the nose wheel steering disconnect memo changes to amber. This happens because ECAM has detected that you are capable of taxiing, but the steering is disconnected. The pushback is complete. Both engines are running and the parking brake has been set on. Notice that when the ground personnel reconnects the nose wheel steering, the amber memo disappears. The ECAM wheel page is automatically called so that, during taxiing, the brake temperatures can be monitored. Part of the after-start checks involves arming the ground spoilers and setting the flaps. We will arm the spoilers for you. You can select the flaps. Click on the flap lever. We have armed the ground spoilers for you. A memo appears on the engine warning display, showing that the ground spoilers have been armed, and the flap indication changes to show the flap setting. Another part of the after-start checks involves checking the status page. As in the example shown, at the bottom of the engine warning display, there is no status reminder. The status page is clear. The APU is no longer required, so we have switched it off for you. All that remains in the right-hand memo area is the parking brake message. The door oxygen page should be checked to confirm that all slides are armed before taxiing. Call the ECAM door oxygen page. On the ECAM door oxygen page, observe that there are no amber indications and that there are 8 white slide indications. You will see more about the door oxygen page in the doors modules. Deselect the door oxygen page. The ECAM door oxygen page is replaced by the wheel page. The aircraft is now ready to taxi. The brakes are released, which clears the park brake memo, and the clock elapsed time is set to run. Select Run on the clock elapsed time. The elapsed time is now running and the aircraft is taxiing out. The flight controls are checked during the taxi out. The ECAM system automatically calls the ECAM flight control page as soon as any of the flight controls are moved on the ground. Approximately 2 minutes after the second engine has been started, a takeoff memo appears on the engine warning display. The takeoff memo lists a series of actions required by the crew to prepare the aircraft for takeoff. If you look at the list, you can see that there are blue action items remaining, specifically setting the auto brakes to max and testing the takeoff configuration. We will set the auto brakes to max for you. The blue action item changed to green and moved. Just before completing the before takeoff checklist, the takeoff configuration test is carried out. This is done by pressing the takeoff configuration key on the ECAM control panel. Select the takeoff configuration key. By selecting the takeoff configuration key, the ECAM system simulates the application of takeoff power. If the aircraft is not in a takeoff configuration, for example flaps not in the correct configuration, then an ECAM warning or caution will be triggered. Provided ECAM detects that the aircraft is in a normal configuration, then the takeoff configuration memo changes to normal. Observe that there are no blue action lines left on the engine warning display. We are now at the threshold, about to take off. If required, the chronometer may be started. Start the chronometer. Observe that the chronometer has started, and when the engines are set to take off thrust, the ECAM engine page is automatically displayed. On the engine warning display, notice that the takeoff memo is replaced by normal memos, and a magenta takeoff inhibit message has appeared. The takeoff inhibit message advises you that some warnings and cautions have been inhibited during the takeoff phase. The aircraft is now airborne. After passing 1,500 feet above airport level, or 2 minutes after liftoff, the takeoff inhibit ceases and the memo is removed. At the acceleration altitude, the climb phase is activated. The aircraft accelerates and the flaps may then be retracted. Click on the flap lever. When the flaps are fully retracted, the ECAM engine page is automatically replaced by the cruise page. The aircraft is now established in cruise. Periodically, a routine review of the system pages is carried out. Call the ECAM engine page. Notice that while the engine page is displayed, the corresponding light on ECAM control panel engine push button is illuminated. You will study the indications on the system pages in the appropriate modules, so let's continue with the review. Call the ECAM bleed page. Let's continue the review. Call the ECAM press page. Call the ECAM electrical alternating current page. Call the ECAM electrical direct current page. Call the ECAM hydraulic page. Call the ECAM circuit breaker page. Call the ECAM APU page. Notice that there are amber indications on the APU page. Because the APU is shut down, these are normal for this stage of flight. Call the ECAM conditioning page. Call the ECAM door oxygen page. Call the ECAM wheel page. Call the ECAM flight control page. Call the ECAM fuel page. After reviewing the fuel page, the cruise page can be recalled. Notice that, as there is no push button to select the cruise page, you have to deselect the manually selected page. Recall the ECAM cruise page. The cruise page is displayed and the ECAM control panel has no lights illuminated. As an alternative to selecting the individual system keys, the All key can be used to sequence through the system pages. You will do this in the ECAM Abnormal Operation module. We will now establish a descent for landing at our destination. As part of the approach checks, the status page is checked. Since there is no status reminder on the engine warning display, the status page is normal. The aircraft is lined up on final approach. As the landing gear is extended, the ECAM system will automatically display the wheel page. The wheel page is displayed to provide information useful for the landing, for example, brake temperatures and spoiler deployment.
On passing 2,000 feet RA with the gear down, a landing memo appears on the engine warning display. Notice that there is a blue action remaining, advising you to arm the spoilers. We will arm them for you.
The blue action line is replaced by a green action completed indication. Notice that there are now no blue action lines outstanding. At approximately 800 feet, the landing inhibit becomes active, and this is indicated by a magenta memo. The landing inhibit message advises you that the vast majority of warnings and cautions have been inhibited during the landing phase. On landing, the chronometer can be stopped to give an indication of flight time. The chronometer only indicates up to 60 minutes and then starts again at 0. There is no chronometer indication for the number of hours. When the aircraft is finally parked, the elapsed time can be stopped by moving the selector to stop. In this example, the block time is 9 hours and 31 minutes. At engine shutdown, the ECAM door oxygen page is automatically recalled so that you can check slide disarming. Notice the pulsing status message on the engine warning display. This is telling you that there is a maintenance-related message on the status page that you have not seen. Call the status page. There is a white maintenance status message at the bottom of the status page. This message is an indication for maintenance personnel that a system requires a maintenance procedure at the next program servicing. It does not mean that the aircraft is unserviceable. Clear the status page. If the aircraft is being completely shut down, the ECAM displays are turned off using the appropriate brightness controls. Normally, EFIS DMC-1 supplies the captain's PFD and ND. EFIS DMC-2 supplies the first officer's PFD and ND. EFIS DMC-3 is available as a backup. Let's see what happens if EFIS DMC-1 should fail. For this exercise, you are the captain, and you are the pilot flying. When EFIS DMC-1 fails, the captain's PFD and ND are lost. Since you no longer have any information to safely fly the aircraft, you should hand over control to the first officer. You are now the pilot non-flying.
Notice that both displays have a diagonal green line across them. The green lines indicate that the displays are working but are not receiving any data. As soon as the ECAM system detects the failure of EFIS DMC1, you will get the normal alerts.
You hear a single chime and see the master caution light. Cancel the master caution. The master caution is extinguished. So that you can carry out the ECAM procedure, we will bring up the lower part of the engine warning display and the switching panel for you. The ECAM procedure requires you to select position 3 on the EFIS DMC switch located on the EFIS DMC panel. Carry out the ECAM action. EFIS DMC3 will now supply information to the captain's PFD and ND. We can now complete the ECAM procedure. After confirmation from the other pilot, the EIS EFIS DMC fault message can be cleared. Clear EIS. The line on the engine warning display is cleared and the status page automatically called. There is a memo to tell you that the configuration of the switching panel is non-standard. Notice the inoperative EFIS DMC1 is shown on the status page. After review of the status page by both pilots, the ECAM procedure can be completed. Clear status. The cruise page is displayed on the lower ECAM screen and the ECAM control panel has no lights on it. A boxed status message appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for an EFIS DMC1 fault. Normally, ECAM DMC3 supplies both the engine warning display and system display. ECAM DMC1 and 2 are available as backup. Let's see what happens if ECAM DMC3 should fail. For this exercise, you are the captain and you are the pilot flying. When ECAM DMC3 fails, both engine warning display and system display are lost. You no longer have any information to monitor the aircraft systems.
Notice that both displays have a diagonal green line across them. The green lines indicate that the displays are working but are not receiving any data. As soon as the ECAM system detects the failure of ECAM DMC3, you will get the normal alerts, but in the meantime,
ECAM DMC1 has automatically replaced ECAM DMC3 in order to recover the system information as soon as possible. You hear a single chime and see the master caution light. Cancel the master caution. The master caution is extinguished. So that you can carry out the ECAM procedure, we will bring up the lower part of the engine warning display and the ECAM switching panel for you. The ECAM procedure requires you to confirm the automatic transfer by setting the ECAM DMC selector to position 1. Carry out the ECAM action. The controls are now in accordance with the system configuration. ECAM DMC1 supplies information to the engine warning display and system display. We can now complete the ECAM procedure. After confirmation from the other pilot, the EIS ECAM DMC fault message can be cleared. Clear EIS. The line on the engine warning display is cleared and the status page automatically called. There is a memo to tell you that the configuration of the switching panel is non-standard. Notice the inoperative ECAM DMC3 is shown on the status page. After review of the status page by both pilots, the ECAM procedure can be completed. Clear status. The cruise page is displayed on the lower ECAM screen and the ECAM control panel has no lights on it. A box status message appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for an ECAM DMC3 fault. If a single display unit fails, there are several ways that the EIS can be reconfigured to ensure that the pilots have all the information that they need. Let's look at several cases.
If a primary flight display screen fails, the screen will blank. There is no green diagonal line since this is a screen failure, not a loss of data. Because the primary flight display has priority, the EIS will automatically transfer the PFD to the ND screen.
If a navigation display fails, no automatic transfer takes place. If required, the PFD-ND transfer switch can be used to manually transfer navigation information to the PFD screen. Should a failure of the upper ECAM display screen occur, an automatic transfer of the engine warning display to the lower ECAM screen takes place. Like the PFD, the engine warning display has priority over the system display. System pages can be displayed by using the system push-button switches on the ECAM control panel.
You have to push and hold a push button to temporarily display a system page. While the system page is displayed, a white light illuminates on the push button. Note, if a push button is held down for more than 3 minutes, the engine warning display screen will be recalled automatically. This happens because the ECAM system assigns priority to the engine warning display.
As soon as the push button is released, the light goes out and the engine warning display reappears on the lower ECAM screen. If you need a system screen, you can transfer the system display to one of the ND screens using the ECAM ND transfer switch on the ECAM switching panel. Click on the ECAM ND transfer switch. By setting the ECAM ND transfer switch to First Officer, the system display has been transferred to the First Officer's navigation display screen. Notice that the ND is replaced by the system display. Normal selection of system pages is then available via the ECAM control panel. In the unlikely event that both ECAM displays fail, the ECAM ND transfer switch can be used to display the engine warning display on one of the navigation display units. Click on the ECAM ND transfer switch. As you can see, the First Officer now has the engine warning display on his ND screen.
If you need to look at a system page, this can be done by pressing and holding the Related System Page push button on the ECAM control panel for a maximum of 3 minutes.
As soon as the system push button is released, the engine warning display returns and the light on the ECAM control panel is extinguished. When you are limited to a single ECAM screen, the handling of system malfunctions and how you are advised of failures is slightly different. For clarity, we will concentrate on the ECAM screen. If an advisory condition arises, the relevant system page is not automatically displayed. Instead, the light on the push-button switch for the system and a boxed advisory message on the engine warning display will pulse. If an ECAM warning or caution is triggered, then there will be no automatic display of the relevant system page. System pages should be called by manual selection on the ECAM control panel. To see this more clearly, let's look at a failure. We will only discuss the one ECAM screen and the selections on the ECAM control panel. You hear a single chime and see the master caution light. Cancel the master caution. The master caution is extinguished. When a failure is detected, ECAM will give the normal oral and visual indications. On the engine warning display, the failure message will be displayed and, on the ECAM control panel, the two clear keys will illuminate. As we are in single display mode, we will now concentrate on the left screen. By looking at the underlined system title, you can see which system page needs to be viewed. In this example, the Press Page push button should be selected and held on the ECAM control panel. The system page can be studied to provide more information about the failure and then the push button released. The engine warning display returns and the ECAM actions can be carried out. We will do these actions for you. Now that the ECAM actions have been completed, only the failure title remains. To confirm what effect the actions had on the system, reselect the Press page on the ECAM control panel. Call the ECAM Press page. As before, the Press page is displayed as long as the push button is depressed. You can see on the system page that the overboard valve is partially open. As soon as the push button is released, the engine warning display returns. To continue with ECAM, a clear key should be pressed to remove the failure message on the engine warning display. Clear ventilation. Normally, the status page would be displayed, but with only a single ECAM screen available, the status page must be manually selected. Notice that there is a boxed status symbol on the engine warning display. The status push button should be held down and the status page reviewed. The status page can be displayed for up to 3 minutes before an automatic return to the engine warning display occurs. Once the review is complete, the push button is released and the engine warning display returns. The ECAM procedure is now complete. There are no lights on the ECAM control panel. During the approach phase, there is no automatic call of the status page when flaps 1 is selected or when QNH is set. To remind the pilot to review status, the box status symbol on the engine warning display pulses. The status page should be selected as before. In this module, we have looked at various failures associated with the EIS. You will have the opportunity to practice the various failures during the simulator phase. The two identical flight warning computers, FWC, receive data from the aircraft system sensors to generate red warnings and the SDACs to generate amber cautions. The flight warning computers then supply the DMCs for the display of alert messages, the attention getters, and the loudspeakers for oral alerts and synthetic voice messages.
Speed, speed, speed.
To begin, we will look at what happens if one or both flight warning computers fail. For a single flight warning computer fault, a caution message will be displayed on the engine warning display. Notice that there are no blue action lines, so no crew action is required. No system page is called because there is no system page for EIS. Clear flight warning system. On the status page, you will notice that the aircraft's auto-flight capability is downgraded to Cat 3 Single. The inoperative systems are Cat 3 Dual and Flight Warning Computer 1. After review of the status page by both pilots, the ECAM procedure can be completed. Clear status. The cruise page is displayed on the lower ECAM screen and the ECAM control panel has no lights on it. A box status reminder appears on the engine warning display to remind you that there is a message on the status page. This completes the procedure for a Flight Warning Computer 1 fault. As a result of the failure, if any other warning or caution is generated, that would light an indicator. You will notice that only half of the lights are illuminated. In this example, with a Flight Warning Computer 1 fault only, the lower part of the captain's indicators and the upper part of the first officer's indicators are illuminated. Note, if Flight Warning Computer 2 had failed, the lights would be reversed. The loss of both flight warning computers will remove the automatic monitoring of the aircraft systems. A message and information generated by a DMC is displayed at the bottom of the engine warning display. There will be no further ECAM cautions or warnings, oral warnings, master caution, or master warning lights. The action lines advise the pilots to monitor the ECAM system pages and the overhead panel for local warnings. Notice that there is a Not Avail list on the right-hand side. The Not Avail items are ECAM warnings, altitude alerts, the status page, automatic callouts, and memos.
The overhead panel should be checked for any local warnings. The system pages can be checked for abnormal indications either by individual selection of the pages or by using the All push button to sequence through the pages. We will hold down the All push button for you to show you what happens. Note, if the All push button is released part way through the sequence, the last page viewed remains on screen.
To finish this module, we will briefly look at the use of the Emergency Cancel push button. It is normally used to cancel an intermittent nuisance message. It may be used, if necessary, to cancel most oral warnings. Let's look at an example of an intermittent nuisance message. When an intermittent caution occurs, the normal oral and visual alerts will be triggered. The Emergency Cancel push button can be used to tell ECAM to suppress the caution. As a result of pressing the Emergency Cancel push button, a white message appears on the engine warning display advising you that the caution has been cancelled. After a short delay, the cancelled caution message automatically disappears and is transferred to the status page. A status reminder appears on the engine warning display, informing you that there is something on the status page. Call the status page. A status page with a white cancelled caution message is displayed. After review, it can be cleared. Clear the status page. The cruise page returns on the lower ECAM display, and a status reminder is displayed on the engine warning display. For the rest of the flight, you will not be alerted each time the ECAM system detects a fault with ILS-1. Now, let's see how you can recall the cancelled caution. Press the Recall push button. If you press and hold the Recall push button for more than 3 seconds, the suppressant function is removed. The original caution will reappear if the fault is detected again. You will have the opportunity to practice the use of the Emergency Cancel push button and the various failures during the simulator phase, so we will stop here.